Hello physics students, this is Dr. Brenzy here, and this is going to be the video for lesson 4.1.3. In this video we're going to be talking about collisions. In normal life you might think of a collision as like an auto collision where two cars collide, and in physics that's certainly one form of a collision, but we broaden our definition of physics to include anything or any moment where there's a brief, intense interaction between two bodies that usually lasts, a very short amount of time, sometimes a thousandth of a second, up to usually a hundredth of a second. That's usually the case, but it doesn't necessarily always have to be the case. So maybe I should put usually right there. So some examples of collisions are, of course, auto collisions. Oops. But there are also other types of collisions in physics. We can think of billiard balls or pool balls. So when you're playing 8-ball pool or billiards, whatever you want to call it, when the balls hit each other, that's a collision in physics. Sometimes, let's see, sometimes hockey players will have collisions. And that's also something that you can handle in physics as long as there's no external forces in the system. Atomic particles. And believe it or not, there are actually collisions in physics that happen when a satellite slingshots around a planet. You might not necessarily be familiar in everyday life of what that looks like, but you could imagine, like, here's sometimes what they'll do is they'll launch long-range probes, and maybe this is the planet Saturn, and what they'll do is if they want to they have a satellite coming in this way, what they'll do is they'll actually have this slingshot around Saturn to gain some energy and change its direction, so that it's now leaving this way. And in physics, we would actually call that a collision. Now, that's a collision that lasts a lot longer than a thousandth to a hundredth of a second, but there are reasons why we can call that a collision, but I'm not going to go into those right now. Okay, so I just want to let you know that a collision in physics is a lot more than just two automobiles coming together and crashing. Now, before I start talking about types of collisions, I need to cover some vocabulary that I may not have covered, that I probably should have covered in previous lessons, but didn't. So, I talked to you in lesson 4.1.1 about systems, a collection of bodies that we're interested in studying, and we know that momentum is conserved in that system when the sum of all the external forces equals 0. But we have a special name for that type of system where all the external forces equal 0, and that's called an isolated system. So I just want to make you aware of that vocabulary just in case you come across it, either in the future or if you come across it down the homework assignment. So collisions between bodies in an isolated system come in 3 different types. Some people will say they come in 2 types, but I'm going to split them up into 3, and I'll show you why at the very end of this, why I decide that there are 3 types. So the 3 types are elastic, completely inelastic, and inelastic. So let's talk about an elastic collision. The reason we call it elastic is because all the objects after the collision return to their original shape without heat loss. So examples of items that would experience elastic collisions might include billiard balls, or pool, if you like to call it pool instead of billiards. Sometimes when two steel balls collide, you can have an elastic collision because they can both recover their original shape without losing heat. Subatomic particles, when gas atoms collide, those are also examples of elastic collisions because they return to their original shape. I'm trying to think of other examples in real life, like a rubber ball bouncing off of a wall. That's an elastic collision because the rubber ball returns to its original shape without losing heat. Generally, anytime you put a spring on a car or on some object and that spring acts in between the two bodies so that the two bodies actually don't collide, but the spring actually separates them again, that's another example of an elastic collision. The reason we call it elastic is because one other name for a rubber band is an elastic, and rubber bands, when you stretch them and let them go, they return back to their original shape. So that's one way to think of elastic collisions, is returning back to its original shape. Now, in elastic collisions, the forces acting during the collision are conservative. So you might think of a spring force. A spring force usually acts between objects, and that spring is a conservative force, that spring force. So anytime you have a force that is conservative acting between two bodies in a system, then you know that you have an elastic collision. So before and after, let's have two particles or two bodies, A and B, collide. And let's think of what happens before and what happens after. So let's have these come at each other. And we can add up their momentum. PA plus PB equals total momentum, P total. We can also say that the total kinetic energy before is equal to the kinetic energy of object A and the kinetic energy of object B. Afterward, we can do the same thing. After the collision, these objects are going to go in opposite directions. We can write down their total momentum. We can write down their total kinetic energy. And we know that in an isolated system that momentum is conserved, so our P total before equals P total after. But with elastic collisions, it's also true that the kinetic energy of the system is conserved. So the total amount of kinetic energy I had before equals the total amount of kinetic energy I have after. So both momentum and kinetic energy are conserved. Now I want to talk about a completely inelastic collision. So one prime example of a completely inelastic collision is a couple of football players who are coming together and one wants to tackle the other. So after the collision, the two are actually joined as one big mass. And that is an example of a completely inelastic collision. So whenever you have two objects, whenever the bodies collide and stick together, that is a completely inelastic collision. So you can imagine before they were two separate bodies coming at one another, but afterward they are joined, they're stick together as one big mass, and they travel in one direction or the other. That is a completely inelastic collision. So momentum is conserved. However, kinetic energy is not conserved. Oops. And one other thing I want to write is that the kinetic energy, the total kinetic energy before is going to be greater than the total kinetic energy after. So some kinetic energy is lost during an inelastic collision. So, an inelastic collision is something in between. So an automobile accident is a good example of an inelastic collision. So these two cars have undergone a collision, but what you'll notice is that they have deformed. They're no longer their original shape, and that's a big hint that you have an inelastic collision. So whenever you have a collision where energy is lost to heat or deformation, then you know that you have an inelastic collision. Now, unlike a completely inelastic collision, the objects here did not stick together. So whenever you have an inelastic collision, you don't necessarily have to have the objects stick together. And that's why I chose to categorize these in 3 different categories instead of 2, because a lot of people, when you say an inelastic collision, will actually assume that it's completely inelastic, but that doesn't have to be true. So in an inelastic collision, momentum is conserved, but kinetic energy is not conserved. And just like our completely inelastic case, the kinetic energy before the collision is greater than the kinetic energy after the collision. Okay, so what we're going to do when we meet next is we're going to start working with these 3 types of collisions. And just to kind of summarize in a little graphic that you might want to include in your notes. So collisions can be split into, and you see here just 2 types. They can be split into elastic and inelastic. Elastic collisions will conserve energy. Actually, that should say kinetic energy. Both elastic and inelastic, you will conserve the total momentum. And if you want to add to this, some collisions that are inelastic are completely inelastic. In completely inelastic collisions, the objects stick together. The objects stick after the collision. All right. So if you want to include completely inelastic, think of this right here as like part of the total possible inelastic collisions here, and some of them are completely inelastic, not all of them though. All right, and that's why I colored a quarter of that. All right, hopefully this was helpful, and I look forward to seeing you next time, and we can start talking about how to conserve momentum and energy in collisions. All right.